The Metadata Versioning System, hereafter referred to as MVS, is a distributed schema tracking framework designed to maintain consistent version metadata across heterogeneous data repositories. The system operates on a single writer, multiple reader consistency model with eventual consistency guarantees. All version identifiers are 64-bit unsigned integers assigned sequentially at the origin node. The core responsibility of MVS is to associate each metadata record with its corresponding version identifier and maintain the complete chain of historical versions. Version records are stored in an append-only log structure. Each record contains the version identifier, creation timestamp in milliseconds since epoch, originating node identifier, a content hash computed using SHA-256, and a pointer to the previous version. The timestamp field serves as a secondary ordering mechanism in cases where version identifiers cannot be relied upon due to clock skew across distributed nodes. Content hashes are used for validation rather than as cryptographic signatures. The version assignment process proceeds as follows. A metadata update request arrives at the origin node. The node increments its local version counter by 1. The new version counter value becomes the identifier for that update. Concurrent requests at the same node are serialized through a write lock on the counter. If the counter reaches its maximum value of 2 to the power of 64-1, the system transitions into a recovery state and does not accept new versions until manual intervention occurs. Version replication to secondary nodes follows a store and forward pattern. The origin node writes the new version record to its local log immediately. The record is then queued for transmission to all replicas. Each replica maintains its own log and assigns local sequence numbers to incoming version records. Replicas do not generate new version identifiers. They only store and index versions received from their origin node or from other replicas during synchronization operations. The version tree structure organizes versions into a linear sequence for each distinct metadata object. Each object is identified by a unique object identifier assigned at creation time. All versions of that object form a single chain where each version points to its immediate predecessor. This structure prevents branching and ensures that the version history remains deterministic. Querying the full history of any object requires traversing from the current version backwards to the root. Garbage collection of old versions follows a mark and sweep algorithm applied at intervals of 24 hours or when the version log exceeds 10 gigabytes, whichever occurs first. Versions older than the configured retention period are marked for deletion. Active versions are determined by scanning the current object state table. Any version not referenced by an active object or within the retention window is swept and physically removed from storage. The default retention period is 90 days. Query operations on versions are performed through 3 primary interfaces. The getCurrent interface retrieves the metadata record associated with the highest version number for a given object identifier. The getVersion interface retrieves a specific version by object identifier and version number. The listVersions interface returns a paginated list of all versions for an object, ordered by version number in descending sequence. All query operations are read-only and do not modify version state. Conflict resolution occurs when 2 nodes generate different versions for the same object simultaneously. The conflict is detected when version replication events are processed in different orders at different nodes. Resolution is performed using the version identifier as the tiebreaker. The version with the numerically higher identifier is selected as the canonical version. The losing version is marked as superseded and remains in the log for audit purposes, but is not returned by query operations. Index structures are maintained to accelerate version lookups. A primary index maps object identifier to the current version number. A secondary index maps version creation timestamp to version identifier. A tertiary index maps content hash to version identifier for deduplication purposes. All indexes are updated synchronously with version record creation. Index corruption is detected during periodic consistency checks and triggers a rebuild operation that blocks new writes to the affected partition. The replication protocol operates in 3 phases: negotiation, transfer, and acknowledgement. During negotiation, a replica contacts the origin node and requests the version identifier of the current highest version. The transfer phase streams all missing versions since the replica's last synchronized version. The acknowledgement phase confirms successful receipt and integration of all transferred versions. If network failure occurs during transfer, the operation resumes from the last confirmed version upon reconnection. Metadata associated with each version record includes the following fields: The version ID field contains the unique 64-bit identifier. The timestamp field stores milliseconds since epoch. The node ID field identifies the originating node. The content hash field contains the SHA-256 hash of the metadata payload. The parent version field points to the immediately preceding version or contains a null value if this is the initial version. The payload size field indicates the byte length of the metadata content. Storage persistence is achieved through a write-ahead log on persistent disk storage. Every version record is written to the log before any in-memory state is updated. The disk write operation is synchronous and blocks until the operating system has confirmed the write. In the event of unexpected process termination, the on-disk log is replayed to restore all version state. The log is organized into segments of 100 megabytes to facilitate efficient recovery. Performance characteristics are as follows. Writing a new version requires a single write-ahead log operation and index update, with expected latency of 5 to 15 milliseconds. Retrieving the current version requires a single primary index lookup with expected latency of 0.1 to 0.5 milliseconds. Retrieving a specific historical version requires one index lookup and one disk read with expected latency of 2 to 10 milliseconds. Listing all versions of an object requires a range query of a secondary index with variable latency proportional to the number of versions. Error handling and recovery procedures address various failure modes. If a version record cannot be written to the write-ahead log, an exception is raised and the operation is aborted with no state change. If replication to a secondary node fails, the record is queued for retry with exponential backoff up to a maximum of 30 minutes. If a consistency check detects corrupted index state, the affected index is automatically rebuilt without blocking read access. All error conditions are logged with timestamp and error code. Configuration parameters control system behavior. The retention days parameter specifies how many days version records are preserved before garbage collection. Valid range is 1 to 3,650 days with default value of 90. The log segment size parameter specifies the byte size of write-ahead log segments with valid range of 10 to 1000 megabytes and default value of 100. The replica timeout parameter specifies seconds before a replication attempt is abandoned with valid range of 5 to 300 seconds and default value of 30. Monitoring and observability is provided through standard metrics and logging. The system exports metrics, including version count, representing total versions across all objects, replication lag seconds, representing maximum time difference between origin and replicas, and garbage collection duration seconds, representing time spent in garbage collection. All operations emit structured log entries with timestamp, operation type, and outcome status. Periodic diagnostic reports are generated containing index statistics and error frequency summaries.